Hello. Yes, we welcome you back to PSSB, Physical Sciences Silver Bullet. And it's me, Richard, once again. Um, Today we are looking at this question. Okay, let us analyze it. It says an object of weight W is supported by two cables attached to the ceiling and wall as shown below. The tension in the cables are T1 and T2 respectively. T1 is 1400 newtons or 1500 newtons. So the question says, calculate the tension T2. And how do we go about this? Okay, this is our T1 and it's known it is 1400 newtons. Okay, so what do we do under this circumstance? Okay, there are so many ways, but let us apply some simple geometry here. If we take this one to be a straight line, and we take this one to be another, I'm trying to construct the components of T1. And from what I'm observing here, these are alternate angles. So what we have here is 36 degrees. Okay, with that the party can start. So we have this component, and remember the component next to the angle is a cos. So what this component is going to be is going to be T horizontal is going to be T cos 36 degrees, and it is known T is 1400 newtons, cos 36 degrees. So what we get out of this, let us get it. So that is what we get. It is 1132.63 newtons. Okay, that's the first part. Now we come to our T2. T2 is also acting two-dimensionally. So it's a two-dimensional force. And therefore we can try to find its component. We can do that. And we can have that. Okay, this is its component, and that's another component. Okay. Do you know this angle? Yes, if we take this line here, this one is 90. So what is this angle going to be? Okay, let us look at it. Okay, 180 minus the sum of these two will give us that angle. Let us get it. So we have got this angle as 25 degrees because 180 minus 90 minus 65, you get 25. So in other words, T2 horizontal, this is T1 horizontal, T2 horizontal is going to be what? Okay, we don't know. It's going to be T2 and cos 25 degrees. That's what we know. You have to remember that if this angle is 25, the component next to the angle is a cos. So we know those. But now I want us to look at this point. What we observe at this point is that we have a force which is acting this side, and we know it is 1132.63. And we have another force which is acting this side, and it is T2 cos 25 degrees. But I want also to remind you that this point is static. It's not moving. It is static. And what do we call that situation when this point is static? We call it static equilibrium. Like for any equilibrium, what do we say? The sum of forces acting in one direction are equal to the sum of forces acting in opposite direction. That one comes up because this point here, which is here, is not moving. So we have the equation. What's the equation? T2 cos 25 degrees is equal to 1132.63. So we are going to get T2, which is equal to 1132.63 divided by cos 25 degrees. Okay, let's get that one. Yeah, so the answer we get is 1249.72 newtons. That is T2. Okay. So what we have just done is a 6.1.1. So what are you going to do? You're going to do 6.1.2. What does it want? It wants the weight W of that mass. Here we'll need to recall also that weight is not moving. And if it's not moving, therefore these are the forces which are acting on it. One, we know it's Fg. Okay. And two, we know that there's a force due to this tension, and there's a force due to another tension. Okay. And these tensions are known. Let us look at here. Remember we said this is the angle. The angle is what? 36. So if this is a component which is cos, which means that the vertical component is going to be sine. So for this one, we know it's going to be T1 sine 36 degrees. Okay, let's come this side. The same applies here. Remember I said this angle is 25, and so we use cos 25 for the horizontal. But now we need to know this component of this tension going upwards, and it's going to be T2 sine 25. Okay, so with that, what do? We go back to the equilibrium situation. We said the mass is not moving. It's neither moving up, neither moving down. So it is in equilibrium. What does that mean? That the sum of forces acting upwards are equal to the sum of forces acting downwards. And that gives us the equation we are going to use. What does it say? The equation says that Fg, this one, is equal to T2 sine 25 degrees plus T1 sine 36 degrees. Here we need to recall that Fg is the weight. So Fg is going to be equal to, so T2 is known. We found it already. We found it to be 1249 0.72 sine 25 degrees plus what? Plus T1. What was T1? 1400 sine 36 degrees. So when you substitute for that, we will get the weight W. Let's do that. So that is what we get after substitution and after pressing the calculator. 1351.05 newtons. That is the weight W. And with that, would like to thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet, and it's me, Richard, once again. See you next time. Don't forget to subscribe. Don't forget to click that like button. It's very, very important. Bye-bye.